In this video, I'm going to show you how to evaluate expressions like these involving inverse trig functions inside of other trig functions when we don't have special angles. We don't have pi over 6 or pi over 4 or pi over 3. So these are not special angles, so what do? As we do this, keep in mind that there are restrictions on the range of inverse trig functions, which can be written as inverse sine with a -1 or arc sine, and so on for the other trig functions. Remember that inverse sine or arc sine can only fall on the right side of the circle. We can only have answers between -pi over 2 and positive pi over 2. For inverse cosine or arc cosine, the range is limited to the top half of the unit circle, from 0 to pi. These are the only answers that are defined. And for inverse tangent, similar to the sine function, inverse sine function, the answers, the range is limited to -pi over 2 to positive pi over 2, but of course we have to leave out -pi over 2 itself and positive pi over 2 because the tangent function is undefined at these 2 points. Y over x would be 1 over 0. That would be undefined. All right, so keep this in your mind as we do the problems. So, an inverse trig function or an arc trig function, which is another way of writing the same thing, is just an angle. So the best thing to do when you don't have a special angle to deal with is to draw yourself a picture. There's no angle that we've memorized that the tangent will give you 4 over 3. So this does not involve one of the special angles. So you just got to draw a picture. Arctangent is just an angle. It's the angle whose tangent is 4 over 3. So let's draw an angle whose tangent is 4 over 3. Now, when we draw these angles, pay attention to what quadrant you're using. Make sure you use a quadrant that's defined. So for inverse tangent, we're only going to use the first and fourth quadrants. Now, we need a positive result, so we're going to stick to the first quadrant. So we're going to draw our angle into the first quadrant. Okay, so I'm just going to draw a triangle, a right triangle. I'm trying to draw a right triangle. Okay, tangent is y over x. So this would be the y value right here. So this must be 4, and this would be the x value, so this must be 3. Okay, so I don't know what this angle is, but I know that the tangent of this angle is 4 over 3. Now, I don't need to know what this angle is to figure out what the sine of this angle is. This expression, arctangent, is an angle. It's this angle, the angle whose tangent is 4 over 3. We can find the sine of this angle without ever actually knowing what this angle is. We're going to need to know what the hypotenuse is. Now, this is one of our Pythagorean triples that we have memorized. 3, 4, 5 is the most common Pythagorean triple. Now, if you did not know that, then you would have to do the Pythagorean theorem. You would have said, you know how we say a squared plus b squared equals c squared? All right, so x squared plus y squared would equal the hypotenuse squared. So this would have been 3 squared plus 4 squared is equal to the hypotenuse squared. That's 9 plus 16. That's 25 is equal to the hypotenuse squared. Taking the square root, the hypotenuse is 5. So this is what you have to do if you haven't memorized the Pythagorean triples. Here's a list of the most common Pythagorean triples. If any of these come up as I'm doing this video, I'm just going to use them without doing the Pythagorean theorem. So if I see a 5 and a 13, I know that the other one must be 12. Okay, anyway, now I can evaluate and say what the sine of this angle is, because sine is opposite over hypotenuse. So that is 4 over 5. All right, so the final answer is going to be 4 over 5. Maybe I'll just put it right here, 4 over 5. So we can find the sine of this angle without knowing what the angle is. It's genius. All right, let's keep going. Arcsine is an angle that we could take the secant of if we knew what it was. Now, we're never going to know what the angle is, but we can draw a picture of it. Where is arcsine defined? Okay, remember that arcsine or inverse sine is only defined for the first and fourth quadrant. So when we draw our diagram, we will stick to those quadrants. And specifically, we want the quadrant that has a positive sign, because 3/5 is positive. So here I go. I'm going to draw my triangle. All right, arcsine is an angle. It's this angle right here. It's the angle whose sine is 3/5. So that means the sine of this angle is 3/5. And we know that sine is the y value, well, it's opposite over the hypotenuse. Okay, so that means this is 3 and this is 5. Well, this is the same Pythagorean triple that I just saw before, the famous 3, 4, 5 Pythagorean triple. So if this is 3 and this is 5, I know that the other one must be 4. All right, no need to do the Pythagorean theorem again. Now, we don't need to know what this angle is to find the secant of this angle. All right, the secant is just going to be the reciprocal of the cosine function. Okay, so what is the cosine of this angle? Well, cosine is adjacent over hypotenuse, so that would be 4/5. So the secant is going to be the reciprocal of this, which is going to be 5 over 4. So that's the answer to number 20. Let's look at number 21. Arcsine is just an angle. It's the angle whose sine is 24 over 25. We don't know what this angle is, but we can draw a picture of it. I'm going to be careful to draw it on the right-hand side because arcsine is only defined in the first and fourth quadrants. The range is restricted. This is positive, so it must be in the first quadrant. Sine is opposite over hypotenuse. So when I draw my triangle, this is the angle in question. The angle whose sine is 24 over 25 must have a y value opposite of 24 and a hypotenuse of 25. Now I could do the Pythagorean theorem to find this unknown side, but this is one of my Pythagorean triples. All right, 7, 24, 25. So as soon as I see the 24 and 25, I know that the other side is 7. Feel free to do the Pythagorean theorem if you want to, but these triples are worth memorizing. Okay, so I don't need to know what this angle is in order to find the cosine of it. The cosine of this angle is adjacent over hypotenuse. So that is 7 over 25. So that's going to be the answer, number 21. Okay. All right. Inverse tangent of negative 3/5. This is an angle. I don't know what it is because it's not a special angle, but I can draw a picture of it. When you have a fraction like this, you can take that negative sign and put it in the numerator or the denominator. And so I always tend to just put it in the numerator. All right, I want to be clear. I want to pick one of these to look at as a negative number. I always pick the numerator. So tangent is y over x. Okay, opposite over adjacent. So when I draw my diagram, I'm going to keep that in mind. Now I need to be careful because the inverse tangent function is only defined, in the first and fourth quadrant. Okay, tangent is positive in the first quadrant, negative in the fourth quadrant. We need the tangent to be negative in this case because we have the negative 3/5. So I need to draw my angle into this quadrant. Okay, so here's going to be my angle right here. Okay, so the negative 3 is my y value. So there's my negative 3, which makes sense because it's going down. The positive 5 is my x value, which also makes sense because that's going to the right. All right, so I've got my y and my x. So we're doing great. Now, we need the hypotenuse. Now, this is not a 3, 4, 5 triangle because the 5 is not the hypotenuse where it should be. If the 5 were the hypotenuse, then I would know the other side is 4. So I am going to have to do the Pythagorean theorem right now. So x squared, a squared plus b squared equals c squared, right? So 5 squared plus 3 squared is equal to the hypotenuse squared. That is 25 plus 9 is equal to the hypotenuse squared. So that is going to be 34 is equal to the hypotenuse squared. So that means the hypotenuse is going to be the square root of 34. Okay, so this is the square root of 34. So remember, inverse tangent is just an angle. It's the angle whose tangent is negative 3 over 5. And that's what we have drawn. We have drawn the angle that has a tangent of negative 3 over 5, opposite over adjacent. Now that we've drawn this angle, we can find the secant. Remember, the secant is the reciprocal of the cosine function. So what is the cosine of this angle? Well, a cosine is adjacent over hypotenuse. So the cosine of this angle would be 5 over radical 34, adjacent over hypotenuse. So that means the secant must be the reciprocal of this. So that's going to be radical 34 over 5. So that is the answer, number 22. All right, let's move on to number 23. Inverse sine of negative 3/4. Well, this is just an angle. It's the angle whose sine is negative 3/4. I don't know what that angle is, but I can draw it. Okay. Inverse sine is only defined in the first and fourth quadrants. So those are my only two choices as far as drawing this angle. I need the sine to be negative 3/4. So sine is negative. If my choices are the first and the fourth quadrants, I have to pick the fourth quadrant because that's where sine is negative. Okay, so sine is opposite over hypotenuse. It's going to be a y value over the hypotenuse. So when I look at this 3 and this 4, I'm going to go ahead and look at this as a negative 3. I could put this negative sign on the 3 or the 4. But if this is my 3 and this is my 4, okay, that's opposite over hypotenuse. Well, the hypotenuse is never allowed to be negative. So, and it makes sense that this y value would be negative because it's down. So there's my negative 3/4 right there. Okay, so this is the angle that we are talking about. I don't know what the angle is, but guess what? I don't need to know what the angle is. I just need to know what the tangent of this angle is. Now, don't get confused. This reminds me of a 3, 4, 5 triangle. I'm talking about Pythagorean triples, 3, 4, 5. But the 5 would need to be the hypotenuse. And the 5 would not be the hypotenuse. Okay, the 4 is in the wrong place. So I actually have to do the Pythagorean theorem. So this is an x value that I'm looking for. So I'm going to go a squared plus b squared equals c squared. So I'm doing x squared plus 3 squared is equal to 4 squared. So x squared plus 9 is equal to 16. So x squared is equal to 7. So x is equal to the square root of 7. Okay, so we just found that this x value is actually radical 7. Positive radical 7, because it's going to the right. All right, you have to pay attention to the signs when you draw these pictures. A lot of students will draw the picture and just leave everything positive. If an x value is going to the right, it's going to be positive. If it's ever going to the left, it'll be negative. If a y value is going up, it's positive, down is negative. The hypotenuse is always, always positive, so never put a negative number right there. Anyway, we don't need to know what the angle is. We just need to know what the tangent of this angle is. Tangent is opposite over adjacent, so that's going to be negative 3 over radical 7. Whoops, why did I put a 3? Negative 3 over radical 7. Now, you could rationalize the denominator if you wanted to. I mean, this is fine for me, but if you want to rationalize the denominator, then you would multiply by radical 7 in the numerator and the denominator. So that would make negative 3 radical 7 over 7. Okay, moving on. Inverse tangent of negative 12 over 5. Okay, inverse tangent is an angle. It's the angle whose tangent is negative 12 over 5. I don't know what that angle is, but I can draw it. Remember that inverse tangent is only defined on the right-hand side of the unit circle. So, as I get ready to draw my diagram, that's what I'm going to do. All right, I'm going to stick to the right-hand side. Now, if I want the tangent to be negative like this, I'm going to draw an angle in the fourth quadrant because everything's positive up there. Okay, so here's an angle drawn into the fourth quadrant. This is the angle that we're talking about. Okay, tangent is opposite over adjacent. That's like saying y over x. Okay, so if this is going to be my y, the 12, it has to be a negative 12 because it's going down. The 5 is my x. That's going to be positive. So negative 12 over 5, that's what we have there. Now, I need to know what the hypotenuse is. This is one of my Pythagorean triples, right? 5, 12, 13. So if I know that the legs are 5 and 12, the hypotenuse will be 13. So you could feel free to do the Pythagorean theorem if you want, but you'll get 13 for the answer. Now, I don't need to know what this angle is. I just need to know what the cosecant of this angle is. Well, the cosecant is the reciprocal of the sine function. So first I'm going to ask myself, what's the sine of this angle? Well, sine is opposite over hypotenuse. That's negative 12 over 13. That means that the cosecant will be the reciprocal of this. So the cosecant will be 13 over negative 12, or negative 13/12. So this is the answer to number 24. Okay, number 25. The arc cosine of negative 2/3. This is an angle. It's the angle whose cosine is negative 2/3. Okay, I don't know what that angle is, but I can draw it. First of all, where is arc cosine defined? Arc cosine is only defined in the first quadrant and in the second quadrant. So when I draw my diagram, I need to stick to those two quadrants. So I'm going to draw my diagram like this, showing only these two quadrants so I don't get distracted. Now we want the angle to be negative. We want the cosine to be negative. So the cosine is negative in the second quadrant. So I'm going to make sure that I draw my angle in the second quadrant. Okay, so this is the angle that we're dealing with, but we can look at this angle as we draw our picture, as long as we use our signs correctly. So cosine is adjacent over hypotenuse. Okay, so that means this will be some kind of a 2, and the hypotenuse will be the 3. Now this is negative 2/3, so it makes sense that this 2 is going to be negative because this x value is going to the left. Okay, so I need to know what the y value is over here. So I'm going to do the Pythagorean theorem to figure out what the y value is. So a squared plus b squared equals c squared. So y squared plus 2 squared is equal to 3 squared. Y squared plus 4 is equal to 9. Subtracting 4 from both sides, y squared is equal to 5. So y is equal to the square root of 5. Okay, so this is the square root of 5. Now, I don't need to know what this angle is to find the sine of the angle. So the sine of this angle is going to be opposite over hypotenuse. So that's going to be radical 5 over 3. All right, so that's going to be the answer number 25. Okay, let's look at number 26. Arctangent of 5 over 8 is an angle. I don't know what that angle is, but I can draw it. I'm going to keep in mind as I do my drawing that arctangent is only defined on the right-hand side of the unit circle. So that's why I'm only drawing the first and the fourth quadrant. we want the tangent to be positive, and between these two quadrants, tangent is positive in this quadrant. So I'm going to draw my angle over here. Now, tangent is y over x, opposite over adjacent. So that means my y is 5 and my x is 8. I'm going to need to know what the hypotenuse is. So I'm going to go ahead and do the Pythagorean theorem. So this would be, a squared plus b squared equals c squared, right? Hypotenuse squared. So that's going to be 64 plus 25 is equal to the hypotenuse squared. 89 is equal to the hypotenuse squared. So the square root of 89 is equal to the hypotenuse. Okay, so this is the square root of 89. I still don't know what this angle is, but that's okay. All I need to know is what's the cotangent of this angle. Well, cotangent is the reciprocal of tangent. So let's start with that. What is the tangent of this angle? That's funny. The tangent of this angle is 5 over 8. So we already knew that. So I didn't really need to, it turns out I didn't really need to find the hypotenuse this time. I should have been more careful. Tangent, cotangent, those are reciprocals of each other. So obviously if the tangent is 5 over 8, then the cotangent is going to be 8 over 5. So I did not need the 89 at all. Okay, this was a waste of time. Moving on. Actually, this video is long enough. I'm going to go ahead and stop the video here. We will pick up with this problem on the next video. All right, see you on the next video. In this video, I am going to show you how to use a calculator to evaluate expressions involving inverse trig functions. So we are going to be using a TI-84 Plus in order to do these problems. So let's see. We have sine, so I can go ahead and just hit sine to get myself started. And then inside of here we have 2 inverse tangent. So I'm going to put 2, and then I will do second tangent for inverse tangent. And then I have 12 over 5. So I could do 12 divided by 5. I have to make sure I just close the parentheses. And then I have to close the parentheses again for the parentheses that's in front of the 2. I'm now closing that set of parentheses. All right, that should be everything. So this is the answer I get. I'm going to go ahead and put 2 decimal places in nearest hundredths, so that would be 0.71. All right, similarly for number 28, we're just going to do the same type of thing. So I have this is going to be a tangent function. So I will go tangent, and then we have inverse tangent. So I will hit second tangent for inverse tangent. And then I have 3/4. So I'll do 3/4. Got to make sure I close the parentheses now. And then plus inverse tangent 12/5. So I'll put plus inverse tangent 12/5, close the parentheses, and then I'm going to have to close the bigger parentheses around the whole problem. So I need to put another set of parentheses at the very end. And that should be it. Negative 3.94 if I round up. Okay. Similarly, for number 29, we have a cosine function. So I'll start with cosine, and then I have inverse sine of 3/5. So here I go inverse sine of 3/5, close the parentheses. Then minus inverse cosine, so minus inverse cosine of 5/13. So 5/13. And again, that's the end, so I need to close the larger parentheses as well, because it's basically like we have parentheses in here, but then we have the larger parentheses. So I need to close the parentheses again. So I'm getting 0.86 if I round to the nearest hundredth. And looks like this is the last question. All right, cosine and now it says 2 arctangent of 4/3. So there's my 2. Arctangent is the same as inverse tangent, so we'll go ahead and just do inverse tangent. And they said 4/3, close the parentheses, close the parentheses, the larger parentheses. And there you go. It's going to be, it's going to be negative 0.28. Okay, that's the end of this video. When you're using a calculator, it just doesn't take that much. See you on the next video.